Thanks for joining the second day workshop of MATLAB. Before going to today's course, I have one question in the chat room. Let me check that. Okay, so Mikhail has a question. When we save in MATLAB, does it save the command window if you didn't type it in the editor? No, it didn't save the command window. Let me go to the MATLAB. So here in the command window, everything in the command window will be lost when you close MATLAB. Only in this script, if they are saved, it will be a script. You see this script here with those icons, right? .m file. These are MATLAB script. Those are in the editor. So here I have a script, example 13 here. A lot of scripts. Each script, when saved into the folder, it will be saved. But the editor, the command window will not be saved. And the workspace can be saved. As we said, you can save the workspace, save, and to save it as a MATLAB data file. So with this icon you see here, this is a MATLAB data file, .mat. So then this saves the workspace, the variables in the workspace. But the command window will not be saved. So if you want to save the command window, I think one way is to you just manually choose where you want to save, and you copy them into some new script. You open another file in the editor, copy them in the script, and then save it as a MATLAB script. All right, so now let's go to yesterday's homework. So have any of you get the ideal result we want here? So how many of you have tried? And if you successfully get to the answer here, you can note in the chat room. If not, you can also mention in the chat room. Oh, great. So David, is it convenient for you to share your answer, or want to talk about how do you do that? Hey, David, do you want to share your code, or talk about? Yeah, you can share a screen. Let me stop sharing.
So Ying, you have to go on the share screen. There'll be a little triangle on the side of it, or a little arrow. Change the settings there so that way you could allow multiple share screens.
Okay, yeah. Yes, I allowed. Hey, David, could you try to share the screen? Great. Yeah, thanks. Do you want to explain what you are doing, David? I can't hear you. Maybe you have a big problem. I can see you typing. Yeah, It's good. Yeah, go on, please. Hey, David, are you muted or can you unmute? Oh, okay, all right, yeah. Never mind. So never mind. Okay, let me try to understand your code. Okay. Yeah, it looks perfect. Right, and then you get the correct answer, right? So let's try that. Great, looks great. Yeah, so unfortunately you can't explain it here. So okay, so I can help trying to help explain your code. So here you are using a for loop. So first we're using a for loop to have an index go from I from 1 to the length of this gene expression matrix. Right? So length is a function in MATLAB. It will give you the length of a vector. And then you basically, I is an index to scan every gene. And then you will compare every gene expression with the threshold. And you use the if statement. When the expression is over the threshold, you're going to print. And in the print sentence, you use the string in the EXP1 genes, which is a cell structure. So we use the big bracket I to take out the ith element as a string, and which will be will replace the percentage s. And then another is the expression value, which is giving the EXP1 result matrix, the ith element, will replace the percentage d. Right, so which is perfect. All right, thanks for your sharing. It's this is a 10-point answer for this homework. Okay, so since David have shared his correct answer, so I don't need to explain to you more. So we can go to the day 2. Do other students have questions regarding this homework? If you have, please ask in the chat room. Because this homework basically cover all the things we told yesterday. So you will need to know how to use a vector matrix, and also beyond yesterday's content, how to use cell structure, and then use the for loop and the if statement. So if you can do that, so yesterday you can manage yesterday's content. Okay, so this is yesterday's content. So we talk about the basic MATLAB usage and writing script and some function, built-in function like size, display, max, cat. And we'll also talk about if-else statement for loops. So today I'm going to start with also something following yesterday. Yesterday we talked about for loops. Today we start with the while loops. So while loops is similar to for loops. It's just a little bit different logic of running the recursion. running the loops. So while it will give an expression. So when this expression hold, and then you will continue to run the statement again and again. Right. So if you have the MATLAB open, could you open the day 2 folder file example 14? It's in the MATLAB day 2 or student day 2 folder. You can go to the day 2. Right. So I think it should be day 2 student and open, double click the example 14. And now, could you adjust this while loop to print from 15 to 25 rather than from 10 to 20? Print from 15 to 25 by adjusting the while loop. Take some time to do this. All right, let me do this here. So when you run this code, you can have from 10 to 19. From 15 to 25, you first need to change the initial value. You see that while loop will print a value when it starts from a equal to 10, right? So you should change the start value to 15 instead of 10. And then you will keep print until 25, right? So how can it print until 25? It's while a is smaller than 26. So then it will start from 15 to 25. See, it start from 15 to 25. So the key here is that the while loop, you need to specify the initial value outside the loop before the loop start and give a termination in the while statement here. So, and then also remember that inside while loop, you need put a iteration rule for the variable, right? So here you see a will be added by 1 each time it runs the loop. So every time you run the loop, a will be added by 1. And at some point, it will reach to equal to 20. And then this while loop will break. If you do not have this sentence of a iteration, then it is a dead loop, right? Because a is always equal to 10. It will all run the loop without stop, right? So you say it's always run. So remember, in the while loop, you need to have some iteration such that the loop can be broken at some point. And so this is the answer. And now could you try to change this while loop to for loop to print out the same thing from 15 to 25? I gotta change. How do we make sure it doesn't print if a is under 15? under 15. Okay, so there we here we have a start from 15. Right? So we have a start from 15, and then it will start from print 15 to 25. So the 15 value is the initial value we set manually, right? We can tune this initial value. If you do not want to print under 15, you just start from 15. If I start from 20, then it will print not under 20, right? So therefore, while loop, you need to specify both the initial value to start and the terminate value, such that you will have a range of this value to scan. Okay, now could you please change this to for loop to realize the same thing? Any question on this by changing to for loop? So for loop, we need to for loop here. You should have for a starting from 15 to 25. And then when a starts from 15 to 25, you don't need to give the iteration inside the loop. And you even don't need to give the initial value, because by having this for loop, a equal to 15, it will automatically starting from 15 to 25. Include both 15 and 25 as the boundary. And you can also give the step length, right? Default step length is 1. And you can also change the step length like 2. And then it will print out from 15 to 25 with step length 2. You see here. So by using for loop, the initial value, the end value, and also the iteration are all written in the first line of for loop. Right? So this way, for loop is actually a bit more convenient than while, because while you need to give initial value before the loop, end value, terminate value, and then inside the iteration loop. But for loop is just specify everything at the beginning of the loop. Okay, let's go back. Any question for this? All right, so then let's move on. So here is a for loop, and while loop can realize the same thing. And also some point we want to have a break statement in the loop. When some condition met, we just want immediately break out. And this is the break statement. Now, please open the example 15 and try to adjust this code to print from 15 to 25 instead of 15 to 20. Please take a minute to try that. Okay, here, so you just need to stop the break, right? So you comment the break and will not break when a is bigger than 20. If I do not have this comment, it will break when it reaches 20. I say once a bigger than 20, it will stop. So this way, actually, you say this is a good way to set some break criteria to the loop. For example, when you run a very big loop and you just need to, for example, you want to scan the gene of a big list, right? There are thousands of genes, but you only want, once you have 20 gene of interest, that's enough. Right? So that there you can use some sentence like this. Once a bigger than 20, then it break. So this way you just need to only get to the 20 things you are interested in, then it stops the loop. So by having this break, you will stop from 20. So now the task here is to to print 20. You just need to stop this break, and then it will continue to print. And if you want 25, you just change this to 26. So then it will from 15 to 20. So there's a lot of also many different ways to that. For example, you can have a up to 100. Right? So a then will be print until 100. But then once you have 25, it's enough. So that you can have a break statement. Once 25, then it's enough. So you will also do this, print up to 25. Right, so this example is just to give you a sense that you can, once you have a loop and you have a break, you basically can control where you want to get out of the loop. Any questions? Okay, so a bit more challenge task for this one is change this code to break once 3 values have been printed. Could you please try this? Change this to break once 3 values have been printed. Right, it's like once I got 3 gene of interest, I break. Please try this in example 15. So this one is a little bit tricky. You can do this way. So here, I can start from A from 15. And then once these three values have printed, that is 15, 16, 17. Right, so now I can set this break statement to be 17. So therefore, it will only print three values, right? 15, 16, 17. That will do. However, this is not the best way to do that. The best way is, what if A start from different value? Right? If I have another user, he just start A from a different initial value, or if I'm looking at some gene list, then I have a different data set of gene list. How does it work for a different initialization? For example, here, if I start from 16, then without changing the code, it will only print two values. And if I want to have three values, I need to get into the code, get into the loop, and change another variable to print three values. Right. So, but I want a code that whatever the initial value it is, it will always print out three values. Once three values one are printed, it will break out. So how to do that? One way is to introduce another index. So this index will be underlying some hidden index. And then this index, well, I start from 0. And it will keep at 1 every time the loop runs. And now my break statement will be when this hidden index is greater than 3. Let's say I start from 1. When it's greater than 3, then it will break. Right, so this hidden index, no matter what A I start from, once it is smaller than 25, it will run from starting value, any start value to 25. But once three values have been printed, it will break out because n will be larger than 3 when this loop runs 3 times. I can try this to see whether it, now you see that I get 3 values. If I start different one from 80, I also get 3 values. And so whatever the A value, once it's below, have 3 values below 25, it works. All right, so this is a little trick to, have an hidden index to always get the wanted number of values to break the loop. Okay, any question for this? All right, so here is the answer. We have the hidden index printed values here. All right, so we can move on. So yesterday we introduced the vectors and matrices. If you remember, when you input the vectors and matrices, you should always use middle bracket and comma to separate element and semicolon to switch the row. Right, so that's the vector and the matrices. So today we're going to introduce a more advanced structure called cell. So cell is before we study the cell, cell is a more advanced data structure. Right? So we actually have met cell in the homework, and it requires a little bit different way of using the bracket. Right? So before going to that, we're going to review the bracket here. So remember that when we define a vector, we use middle bracket and the semicolon to switch the row. Now we want to get to the ith element of a vector. So then we use small bracket. Small bracket is to call as element of a defined vector, right? So when you define vector, you use middle bracket. But when you want to get certain element out from a vector, you use small bracket. You can sort of think a vector which has been defined as a function, right? So this one is like a function. It has several output units, and you want to take the third units. And remember, when you put argument to a function, you use small bracket. So that's why it uses small bracket. And we can have some tricks to handle the element in a vector. For example, you can try this one, v small bracket code here. So this way you will get all the element in the vector. So code simply means from 1 to the end. 1 to the end. And if you want to get from 3rd to 6, you just type from 3 to code 6. You can try this in your command window. If you have tried, then here is a more complex one. So when we have a matrix, it is basically similar. We have a matrix here, A. You see that is a 4 times 5 dimensional matrix. And I want to take out the n row and nth column. I use the small bracket. Like 2, 5 is 2 row, 5 column is 6. And when you define matrix, remember that's middle bracket, right? And also note that here we use space to separate the number in each row. So when you separate the number in each row by space, it's equivalent to separate them by comma. So you can use both, or you can use either a comma or a space. So then the first row has 5 elements, semicolon switch row, and then repeat, then you have this 4 times 5 dimensional matrix. And then when you want to get the nth row and nth column, remember to use small bracket. Now you can try this example by yourself in the command window. Same thing here. You can use code to take out several elements in the matrix for each dimension. Like the first one here, A code 4. So code means take all the rows, all the first dimension, all the rows, and 4 is fourth column. So I will take all the rows in the fourth column, which is this column. And similarly, fourth row and all the columns, right, which is this row. So, and you can also take the from 2 to 3 rows and 2 to 3 columns, which is this matrix block. 3, 4, 4, 5, this matrix block. So question for you is how to take the last 3 rows, for this matrix. You can try to type any matrix, like here, A, and then take the last 3 rows, all the elements, last 3 rows, all All the column, last 3 rows. Try this in your command window. All right, let's try this here. I have a, let's say, a matrix. I have defined like this one. And so this way, each row I define a vector 5 element, and then different rows I repeat some different way of defining the vector. Right, so it's a 4 times 5 dimensional matrix now, which is A. And I want to take the last 3 rows. And so here is a trick you can do this way. Last 3 rows, if you know the rows of A, you can take from 2 to 4 rows and all the column, right? 2 to the 4, which is 2 to the 4 last 3 rows and all the columns. You can see what it looks, right? So then that's the last 3 rows of A. And you can also use a bit more tricky one. You can use this one called AND. So it has an AND. Let's first say what AND will look like. So AND will take the last element in that dimension. So AND will be the last row and all the column. So it's for this row. So the last 3 rows would be AND minus 2 to AND. Right, so AND minus 2 to the AND. So this should be the last 3 rows. Right, so you say that's the last 3 rows. So just remember there is a tricky code called AND, which will take the last element of the vector matrix. So, so this one will be useful when you do not know exactly what's the dimension of A, right? So here we know A is 4 dimensional. Then the last 3 will be 2 to the 4. However, if later you want users will put it in different dimension matrix, you don't know the dimension in priori, then this code will be the one that will always take the last 3 rows. Any question? Okay, good. Let's move on. So we have more convenient way of doing the define the matrix. This is by the built-in functions like zeros and ones. Zeros are all 0, ones are all 1. And you can specify the dimension of this vector. If you only give, so remember now here, zeros and ones are functions. So when you put an argument for function, it's always small bracket. And 3, if you put a single value, it will by default give you a square matrix with this single value. You can try once 3. This is what it gives to you. It should be a straight times straight square matrix. If you want to specify the row and column number, you just give 2 number. This also works for zeros. And so this way you can define a zeros matrix and a ones matrix. Any question before we move into sum? Okay, actually we can have a 5 minutes break before we go to the cell, because cell structure is a little bit difficult. So I want to have a fresh mind before we teach cell. So let's have a 5 minutes break. All right, let's start it. So cell array is like a matrix, but it's more convenient to use once you know how to use it. So we have seen example, which is gene names in the homework. So our question is, why do we use the cell array for the gene names instead of matrix? So you can actually try to put the gene names as a matrix, right? So remember, when we define matrix, we use middle bracket. And when we put string, we add a single quote. And then you see here that you can put the gene names. However, if you do this, you can see that you get this string, just string combined. It's not separated. And you can also try to, how about we switch the rows and put a column vector. Each row will be a gene name. If you try that, you see that it will not be concentrated, because each row of the vector in this matrix have a different column number. The first row, IL1A, will have 4 columns. The second row will have 6 columns. But then these vectors cannot be aligned as a matrix because their column dimension does not. Right, so in this way, you can see that matrices are very bad to deal with strings. If you really want to do this, then you need to manually add some space here to make their column number match. But then it will be very inconvenient. So that's why we use cell. So cell can put anything in each unit. Anything, I mean data, numerical value and strings and even matrix. So any unit in your cell can be put any data structure. Each unit in the cell can be put any data structure. Like here we define a cell. When you define a cell, you need to initialize it by a function called cell. And whenever you call the function, use a function, use small bracket to get it, to put it argument. So here it's a 2 times 5 dimensional. So now it has 10 units. The first unit, I will a string, IL1A, and the first row of unit are all strings, and the second row of unit are numbers. If I put the cell this way, then I get a 2 times 5 dimensional cell. And when I define the cell, when I put the cell, I use big bracket. Right? So that's the only thing you use big bracket. I mean, for most of the time, the only thing you use in MATLAB that have big bracket is to define the cell. When you have this one, then you see the cell has a very composite structure. Right? So it can have strings and numbers together. And now you have defined the cell. What about we want to take out some element in the cell? So this is also a tricky part. You have 2 ways. One way is to use small bracket. So n refers to the cell. So another way is the big bracket. So the key difference is that when you use small bracket, it takes out the set of cells. Right, like here, I use code 2 to the 3, and then I have all the rows and the 2 to the 3 column, I have this 4 element of cells, right? So it's a set of cells. It's a set of cells. It's a sub block of the whole cell matrix. Right, so that would be my answer. So it is still a cell, but with just a sub block. If I use the big bracket, then it will refer to the data inside the cell. Right, the same index here, but with big bracket. Then it would give every element unit by unit in that cell. Right, so the first unit will be the string. Right, so it will print out the string. And then the second unit, the third, fourth. So it will extract every unit inside the cell. Right, so there's 2 different ways. So this will be very important when you code, because if you use the first way, the output is still a cell. If you use the second way, the output will be the data structure inside that unit. It can be a string, it can be a matrix, right? So the data structure are different by these 2 ways. The first is still a cell. It's just a sub block of a big cell. But the second is take out the units inside, the data inside that unit. Right, so that's a key difference, very important. Because sometimes when you want to use a data inside a cell, let's say if I want to take out what's the value of IL1A, I will print out this value, right? So therefore in the sentence, I will use a %d. Right? %d is to take out the numerical value. Then I need to use big bracket to take out this value. If I use small bracket, it will not work because the small bracket will take out the subunit as a cell. It is not the data inside that unit. Did I make this clear? This is very important. This will be some of the questions in the final quiz. Do you have any question? Let's try this. I have A, 2 cell. So I have, I define the A first element to be 1. And you see it's a 2 times 2 dimensional cell, but with only the first element to be numerical value. I define the second element, the first row, second column element as a string. And you see the second element was 0. And even when I define, I cannot use small bracket. Let's say, because when you use small bracket, you take out this first row, second cell, second column cell. But that cell, the left side is a cell's data structure. The right side is a string data structure. So these 2 structures cannot be converted, right? So you can only make the data inside that cell unit to be any data you want, like string, right? This way, I'm telling the software that I want let the first row, second column data inside that cell to be a string. So then it will be a string. Or the same thing when I want to print out them, I want to take them out. If I print this, A12, then I get the answer is 1 times 1 cell. And inside the cell, I have a data string S. Right? So it is still a cell. But if I use big bracket, then it is the data inside that unit. It is a string. It's directly string. I got a question. Okay. So this one is the key difference for the cell. Very important. It's easy to make mistake in coding in like my coding. Sometimes I could get this wrong. Just remember, small is take out the cell sub block. Big bracket is to take out the unit inside the cell. All right. So if no question, we're going to introduce a function for our later usage of define of a difficult task. So this function is called string comparison. Its name is strcmp. It will compare two strings. If these two strings match, then it returns logic value 1, otherwise 0. So now, could you open the example 17 in your code, in your folder? And then there is a task is you compare the gene list to say whether you have a gene called IRF1. And so this gene name is saved in a variable gene of interest. Once you compare the gene list element with this gene of interest. If there is one match this gene of interest, then print out its expression value. And so just recall that all the other code written here are our homework yesterday. It's just additionally, we want to have a code of comparing the gene names and find the gene of interest. Please open example 17 and take 3 minutes to do this. Sorry, I guess my internet just offline and then it's now reconnected. Okay, let's start from the example 17 here. So have any of you get the answer here? To print out the gene name of interest? Or do you have any question, problem when you're doing this? Oh, great. Yeah, take your time. Take another 2 minutes. Okay, let's try that together here. So here we just want to realize another task is one, when the gene met with the gene of our interest, right, then we print out its value. So it's another if statement, right? So before we have, when the gene expression value is over the threshold, we print out the gene. Here is just compare the strain. When the strain is matched with gene of interest, then it will print out. And we have just introduced another function called the string comparison, right? So string comparison, if I remember. And then string comparison need to input two arguments, the first string and second string. And first string should scan the gene name list. And we have just introduced the cell, right? Whenever you call this data inside each cell unit, use big bracket. Big bracket I is the ith gene name in this list, in this gene name list. And I compare whether that is matched with my gene name of interest. And once it matches, it will get into this if statement and print out the gene name and the gene expression. So that's what I should do. So the only change to the upper if is that we use a string comparison to compare the gene name instead of compare its value to some threshold. Right, so now we can see the result. So you see, when I get the RF1 gene, even though its expression is below 3, is below 20, right? So it's not a gene over the threshold. It was still printed out because that's a gene of our interest. And we find the gene of our interest and print out its value. Right, so that's the way to do that. The key is use a string comparison function and also use the cell structure, the cell data inside the cell. Right? So use big bracket. So that's two key for this question. Any question on this problem? All right, let's move on. So this is the result. We see that we print out the gene of interest here. So another related question is how to print out this gene at the end of this loop printing, right? So here is in the medium. It's when I go through the gene list, I go one by one. I go from first, second, and then I reach the IRF1 is here, and I find is my gene of interest and print it out. So that's why it's printed in the middle, and then I keep going the gene list. And I found other gene over the threshold, I print it out. So how to adjust the code to print out the gene of interest only after or print out all the genes over threshold? Right? Could you try to adjust this code and print out the gene of interest at the end? Is the problem clear? If not, you can ask. Yeah, I got a answer here. Could we put the string comparison in separate loop after the threshold comparison? Yeah, it's a good question. We can have another loop, and then only compare the gene in the other loop. However, that is a cost is that you need to have two loops. Right, so we have two loops, the computational times double. And here we don't have any feeling about that. But imagine if I have thousands of genes, right? So when you scan one gene or even more, or even millions of data, right? Like currently machine learning have millions of images. If you want to do that, then If you have two loop, the computation double. If you have some computation time like a day, and then when you double, you need 2 days, right? So in principle, you can put a different loop, but when you have more experience in coding, then you need always think about how to save computational time. Right, so this, by having another loop, well, is a correct answer, but it's not the best answer to print out at the end. Just to think a bit more, how to use one for loop to achieve this, to print out the things at the end, to print out the gene of interest at the end. You can print after the for loop ends. You can try that and see whether that works. Right, if that's a goal. We want to print after the for loop. But how to do that? How to achieve that? We can print the RF after RF1 after the for loop. Okay, let's try this together. If you have tried, let's try this. Right. So as some of you just speculate, we can try to print out this after the for loop. I have this. If I do this, what will happen? Let's try. Where you see that we print out everything over the threshold, but we didn't print out the gene of interest, right? Unfortunately. Why? Because when we run after the for loop, the I will be equal to the end value here, which is the last gene. Right? You can even say that the I in the workspace here, I is 7, which is the last number of the gene. And now you compare the string, right? So you basically only compare the last gene with the gene of interest, which is MYC, MIC. It is not the gene of interest. And then this if doesn't met, and so you will not print out anything. Right, so basically this if statement doesn't execute, it's wasted here. Right. So then how do we print in the end? So here there is another idea is, when we run a for loop, or do we just want to run once? So instead of print here, right, you don't print here, but you record that search. You record that search. If I find the gene of interest, and I can record the expression of interest, to be this gene expression value of my interest, right? So then this will run the for loop. When it finds the gene of interest, then you just record the gene value of interest to be this new variable I define, right? So here I define this variable. I can also first give it a 0 value. So then in the end, I can have an if statement. If expression of interest bigger than 0, right? So when I run this for loop, if I found this gene of interest, it will give its expression value, which is have some finite gene value, right? It's non-zero gene value. So if I find this gene of interest, this variable will be larger than 0. If not, it will be 0, right? Because initially I set it to be 0. So when it's bigger than 0, it means I found this gene of interest during the for loop. So now I can print. I can print what? Print the gene name, which is the gene of interest here. And then the expression of my interest gene. Right, so by having this, you basically first for loop, you record whether you find this gene of interest. If found, we get its expression. And then in the end, I just need the if statement to say whether I found. If I found, I print. Right, so let's see how it works. You see that it print out my gene of interest in the end. Right, so here, I think that this is also a good exercise for you to have get some idea of how do you design the code. All right, so by using for loop, you don't need to necessarily to print out everything inside for loop. You can record the result you want during the for loop, and then do the print or other thing after the for loop. Any question before moving on? So here is our answer here, right? So basically compare strings and print out the gene at the end. So here it doesn't have if statement because if there is no gene, right, so it will print out the expression of gene of interest is 0. And so whenever I say if the last output is 0, it means I didn't find the gene of my interest. So this way of coding is a little bit might be a little bit confusing than what we just code. So it will still print out the gene of my interest if it's 0. So then you need to know that whenever it's 0, we didn't find the gene. Okay, lastly, we go to the function. We have a total about scripts, and the most difficult part is the function. Actually, this problem here is really almost the most difficult in this workshop. And so the most difficult will be the function. So function we have made before. So it's like ones, zeros, size, display. These are all functions. So now our goal here is to define function by ourselves. Because previously the function we used a built-in function in MATLAB. So here we just want to define function. Define our own, we create function by ourselves. So its schematic is we should type function, and if the output is some outputs, some data, and we use the middle bracket equal to function name. We give a name and the input argument, small bracket. So that is the schematic. Let's say example. This example, reverse-seq, is to return a sequence with inverse order. So how do we do that? We define the function. The output will be out sequence, which will be specified below. After you run this function, you gotta have somewhere that will give this output sequence some value, right, as the output. And then this function name, and then the input argument. So you will use this input argument variable seq, seq, use the input and do something and then get the output. So this function is reverse the sequence, so it's easy. You just reverse the seq from end -1 to 1, right? So this will go from the end to the first. And this will be my output sequence. And so it's basically one line of code will give you the output. And then you just write in this format to define a function. So here, this is the function you define. And next, you can use this function. How do we use this function? Remember how do we use once? You just type once, small bracket, give it an argument, right? Zeros, small bracket, argument. That's how we use function. Here you use function. You call this function, its name, small bracket, and give it an argument. The argument is a sequence, right? Because we should give a sequence to this function and then the reverse order. So sequence is a string. We give it a string, TC, GCG. So this is like a gene sequence. So then this function get this argument, it will get into the function, get the reverse sequence and output this reverse the sequence, right? So the answer will be the GCGCT. All right, so I hope this simple example can help you know how function works. When you create a function, you need to specify its output, name, input argument, and do whatever for the input to generate the output. And when you use the function, directly call its name and give an argument. So therefore, you see that function will be very convenient to use. Whatever the code we wrote before can be defined as a function. And then next time you want to run that part of code, you just call the function, give it an input argument. Then everything will be, you wrote as a code will be packed, and you directly get the output. Okay, so let's say an example. Let's try ourselves. So please open the print gene expression.m script in your folder. I think it's the same folder. And change this to be a function, right? So look at the inside code here. It's the code we wrote before. It's to compare the gene. We have a gene list and their expression. We get the expression over threshold and get the gene name of our interest, right? So that's what we code before. Now we want to pack this code into a function such that later user can give some input. Here we give a gene name list, expression, threshold, and our interest gene, these 4 arguments. And then I just run this function called print gene expression, input these 4 arguments. It should give the output we made before, right? So by creating this function, we can allow other users to use this function. We can give a different gene name list, right? Like some experimentist give me a new data set. It's a new gene list. What I will do is just to insert this new gene list as my argument to this function, and then it will automatically work for the new data set. Right, so please try to change this script into a function based on the code below. And then you provide this argument externally in the command window, right? Like this 4 argument, and then use this function to see whether you can create a function. Please take 5 minutes to do this. This is most challenging part in this course. Okay, do you have questions? Okay, let's try this in the MATLAB. Okay, we want to change this file into a function. And so here is some guidance here. So first you should add the function name. And to add that, I have it here actually. So I have the function name. So you define the function. You want to give the variable output as you later specify this output below. And this function has a name print gene expression. It has some argument. So here you can give any variable name to the argument. But once you give it a name for this argument, you need to use this variable inside the function. Right. So here I use this first argument inside as my gene expression name list. Right. So this argument will be put by user output when they use this function. But whatever they put there as a gene name list, it will be defined as this argument names. And then this argument will be further given to this EXP1 genes. Right. Why do I want to give it to be EXP1 genes? Because previously we have write a code of using this as the gene name list to do the following task. So that's the reason why I pass this argument to some inner variable. The same goes for other argument. I have the gene expression value, threshold, and gene of interest. So the next thing is that I run this code, right? So which is exactly the same code we wrote before. Then the only thing is I need to give the output, right? So this output should be given after I run this function. So I just define an output variable as my gene of interest. Right. So once you run this function, it will go through the gene name list. It will search the gene over the threshold and compare the gene to find my gene of interest. And also output my interested genes expression, right, as the output of this function. Right. Do you have any question on this logic? If not, we can try this function. Right, so we already have a function here. So how do we use this function? So when we use this function, as a user, we should provide the variables, right? My data, where I should provide some data to this function, and then use this function. So I just directly copy this. And so this is our variable. Sorry, let me start. Start by clear everything in the workspace. Now I restart. You can see that all the variables are defined in my workspace now. Now I can input this variable to this function, to the function I wrote. Let me check the chat room. Could you explain again why you use names in the function instead of just calling it exp1? Okay. So here, when I define the function, I should give a variable name to its argument, right? So I can name it as argument 1, let's say. All right, but then this first argument, I know I will tell user that the first argument should be the gene name. And then later user will put the gene name in the first argument of this function. Right? So then this first argument inside this function should be the gene name, and I will use later, right? So I will later, previously I write the code exp1 genes as my gene name. So just pass this first argument to my gene name list I wrote before, right? So you see the code we wrote before. exp1 genes is the gene name list. It's just that now the gene name list will be given externally by the user as the first argument of the function. And alternatively, actually, you can do this. You can directly do this. You can name the first argument as exp1 genes, which will be provided by user externally. And then inside the function, you directly use this first argument as the gene name list in below, right? So here, you scan the gene name list, compare the string. And so these are two different ways to do that. But this is, I mean, they're actually equivalent. It's just the functions. Here we just use a different variable name for this argument, and then pass this argument to the inner variables. Great. So once we understand that, then we have defined all the variables externally. So this will be my argument to input to the function. How do I call this function? I call its name, and I give it an argument. So now here, names, this cannot be, no, I don't have names variable in my workspace, right? So I should change the names to be my gene name list, which is exp1 genes here. And then gene expression, threshold, and gene of interest. Right, so that pass all the data externally defined to the function. This will work, should work, right? So you see that they print out all the gene over the threshold, and also give the output answer, which is the expression of my interested gene. So now the code we wrote before becomes a package, a function. A function is a simple package, right? It's just a very short package, and then users can give a different gene. Let's say you have some collaborator, then the collaborator will give you the whole genome of a human, whole gene name list of human. Actually, we will do similar task soon. Then you can give a different gene, AA, and their expression value will be some measurement from experimentist, right? So then it's a different data set, and then you run the same code without changing anything. Run the same function, then we'll give you the result. So you don't need to do anything else, just to change the input. So this will make the work very easy once you have a packed function. So from this example, you can see that why do we want the function? Because it's just make life easier. You can pack every code you wrote as a function and just change the output, change the input. So the key for the function is to specify the input and put an output. Okay, now the last challenging task, the most challenging task is we really want to use some measurement data, right? To load data from a file that some experiment is generated to you. And then load that file to do the same thing, to compare, to find the gene over threshold and find our interested gene. So that's our final task of using the function. So here, to do that, I introduced a function, built-in function called import data. So this is a MATLAB built-in function. It will load the text file. Right? So what we want to load is a text file, txt, text file. And typically, like when you do some RNA sequence measurement or some different measurement, one output of their measurement is a text file or Excel file. These files, they can all be loaded by MATLAB. So here is an example. We load the file. This file will be given in the variable name called input file name. And so the import data function also has some usage of using this delimiter and headlines. So you actually don't need to worry too much how to use the import data function. Right? How to use the function? Why do we put the delimiter headlines here? We don't need to mind that because it's after I read the documentation of import data and I find this way of using this function will correctly load the data. Right, so that already gives you the this piece of usage for this import function. Then also here, once we load the data, it will be given as a variable A. So this variable is a new data type, is called structure. We didn't talk about structure before, but the structure is just also compose the data with different field. And by calling it a field, you just use dot, a field, and it will load the corresponding field. Let's see in the MATLAB. Now you can also open the, I think this is a print gene expression from file, this script. Print gene from file, this script. Okay, so you can try this. Let's try this. Let's clear everything. Let's just try this in the comment window first to see what we can get by loading the data. Okay, so now you see it says undefined function input file name because we didn't specify what's the input file name, right? So we don't tell it what file it should load. So here we have, I think in the files I sent to you, there is one file, experiment1 text. This is a file, right? So its name is experiment1 txt as a string. So here, this is a way of using the built-in function import data. And we have a file. Let's open the file to see what it gives. So this file, I double click, you see that this text file has a lot of data. I mean, relatively to what we did before, it has many data. Has several. So first row has, it's just the different field, different names for the data I have. Like the first column is gene, and second is their function, and many others. Right? So what we will use in this task is only their gene name, right? So basically the first row, and their expression in the last row. So the visualization of this data format is a bit weird, right? So, but don't mind that, because the value, like for example, the value is like the last row here, and the last row in each, the last column in each row. Right? So the last column is a gene expression, and the first column is gene names. Those are only two rows we will use. Okay, so now we import data. We use this function, and we will get a variable called A. A is a structure you can double click, right? You see after double click this variable in the workspace, right? So if you can try, you can try this in your command window. Double click A, and then it has two fields. It is structure with two fields. First field is called data. So you can double click data, and you see that's all numerical value, right? So that's a MATLAB numerical vector or matrix. Right? So it's a 9 times 1 dimensional matrix. This is the gene expression value. And you can also double click the text data. This is a cell. Right? You see, that's all the other information in the text file. Function, reference, and gene. So what I actually need is only the first column in this text data. It's their name, their gene name. Right? So that's like above blimp1. That's their gene names. Right. So by having this, you can see we have in this code, we have used the a.text data from the second row to the last row and the first column, right? So this is the a.text data from the second row to the last row, first column is all the gene names, all these gene names. This gene name will be saved, just saved into the variable we used before, exp1 genes. This will be my gene name list. And a.data, see here, a.data is just their expression value, the expression value of the genes, right? So it will be saved into the exp1 result. So is that clear by using this function? So basically I have just explained what is the output by using the built-in function to load the data. Okay, so once we have that, we basically load from the file to get all the gene name and the gene expression. Right, so this is like your collaborator gave you a file of their measurement. Now you load that file and get the gene names and the gene expression. Okay, then once you get that, everything else is the same. Right, so you already have the gene name and the gene expression. Everything else is just to use the function we wrote before to then input the argument as names and expression, and then find the gene over a threshold and gene expression over a threshold and the gene of our interest. Right. So now the task is for you is to, we have to write this function, print gene expression from file. We have to write part of it to load the file, right? So we can load the file from this code. And the task for you is to, when you load the file, please call the previous function we wrote before, print gene expression we wrote before, and do the same task to print out the gene over threshold and the gene of interest. So the difference compared with our previous task is Now we load the files. Load the gene name and the expression from files, and then do the same thing. Okay, so this will be a task for you to do. This might be more challenging, so take some time to do that. We will soon explain it. Please take probably 5 minutes or more to do that. This is the most challenging task in this workshop. All right, any question? Does some of you work it out? All right, do you need more time? Okay, great. Give me more time. All right, let's do this here. So here, it's a bit difficult because we're going to use a nested function. So here, the goal here, the final goal here is that later when I use this function, I use this way. Right. So let's before that, let's clear that everything, and let's first give the gene threshold and the gene of our interest. And we will also give an input name, right? So the input name. So after we giving that, we will give the input name here, give the data experiment 1. This is the input file, the data file. And then we give these 3 arguments to this function, print genes from file. And then you will search all the gene in this data file, find those gene over threshold and the gene of interest. Right? So that's the goal, the final goal. So how do we use this? How do we create this function to achieve that? So you see that once I give the gene expression name, then inside this function, it will use this name to use import data to load it, right? Remember that we have just used this function to load the data file, experiment 1 text. It worked, right? So it worked. You will give the gene names and gene expression into these variables, and you will be able to just load the file and save into variables for later use. So now the rest is, now we'll have the gene list, gene expression, and the gene of interest and threshold. Right, these 4 variables we already have inside this function, right, inside this function. And the only thing now here is just to use the previous function. Right, if I can even directly copy the previous we wrote. Right, so this function, when we have defined this function before, right, we give it a gene name, expression, threshold, gene of interest, and then we directly go to use this function. Right? So here it's inside this function, print gene expression from file. You call the previous function we defined. Right? You just use the previous function. And then the 4 arguments, let's check here, the gene name, right? So which is loaded from data, the gene expression, which is loaded from data, and threshold, which is passed from the argument, of this function, right? And then the gene of interest is also passed from this function, right? So it's actually very straightforward, right? Once you know how to use function inside a function. Okay, then the only thing we also need to do is to have to give the output file as the output of this function, right? So this will generate the output from the print gene expression, the previous function we wrote, generate the output and pass this output to the outer function. Right, so now the function is done, right? So we can use this function, here. You see that I need to input 3 arguments. 2 of them I have already defined. It's the gene of interest and the gene threshold. And now the only thing is the data file. So this should work. Let's try. So you see then it will give all the gene which is over the threshold, has expression over threshold. Remember here, E plus 0, 1 is the scientific notation 10 to the power of 1. So it's here it's a 32.47 and so on. So these are all the genes over the threshold. And I also get the answer 0, so which tells I didn't find the gene of interest. Right. So in this data list, I don't have the gene IRF1. Right. Alternatively, if I try whether I can find, let's say CCL20, right? Let's see whether we can find CCL20. Just wrong. Okay, we see that we got the expression of CCL20. Right. So here the number is in different format. We can probably change the format of number into like format we did before, short, right? To see whether that will give the default format. Okay, that's the default format we have. Right, so give the number. Okay, so that's all you need to do. So basically, use the previous function we wrote in the current function. Right, so in the current function, we use the previous function we wrote. And this current function just have additional things of load the data file. Load the data file here in the current function, and then use the previous function. In the previous function, it goes through the gene name list, gene of interest. So that's where it's like step by step we define the nested function. And so then this one is like a package, right? So then you can tell the user you just need this one line of code. Once you have this data file, you specify the gene you want to have, the threshold you want. And then you run this line of code, and then it will give you the output. Right. So by this way, by defining the function, we can really create a very composed use of realize some tasks. Okay. Any question? So this is the most difficult part. Question before. It's actually the end of today. And so this is the most difficult part. Please, if you do not fully understand it, you can ask now, or you can also think about it later today. You know, this we use function inside function. Of course, if so this is the answer. If we just call the previous function we wrote before, and then later we just use the current function to give the input file. Right. So the homework it would be, you know, add some code to not only load the file but also write the file, the gene over threshold and gene of interest into a file. All right. So to do that, we need to use some built-in function like fopen, fclose. So this fopen will open a file with a name which is writable, W is writable, and this file will be feed, and then we will use fprintf feed some text. This text will be writing to that file, and then in the end you close that file, which will save that file to the current folder. Right, so this will be the homework. If you can give it a try to see whether you can just change this function we wrote before to have output. Right, you just pass the output name into the inner function, and the inner function should have some code to write out the file. Okay, so that's all we should do here. And if you have any question, you can stay and ask. Otherwise, you can spend some time to do this homework. And that's all for day 2. Tomorrow will be a bit easier to do some plotting. So that's all for today. Thank you.